Hello everybody and welcome to this session. We are going to build a digital asset manager and we are going to do this together with the power of AI, specifically the Azure Cognitive Services. I'm sure it's a common struggle. You have searched way too many combination of words to find the image of that video that you need and it's still not popping up, isn't it? What if you could automatically add metadata, tags to any image or video that you upload, say, to OneDrive for Business and move it to the right folder with no manual effort? So in this session, I put together a quick guide to show you how to build a flow. We'll be using Azure Logic apps for that to integrate OneDrive for Business with the image and video also recognition API in Cognitive Services, computer vision. Logic apps makes it easy to integrate multiple API, and Cognitive Services quickly analyze images and return tags to be used as metadata. I'm sure I don't have to do a big introduction about Cognitive Services. Azure provides these services as an API, a REST API with pre-built models for you to get started immediately without being a data scientist, without a background in artificial intelligence or machine learning. Computer vision specifically is the capability that we are going to use. Computer vision is part of the Azure Cognitive Services and has many flavors, many capabilities. We'll focus on image recognition, so identifying objects inside an image so that objects can be used for tagging, adding metadata, and categorizing that image automatically using Logic apps into a folder structure. Computer vision works on the basis of identifying rectangles or areas where objects exist inside a big picture. But we'll focus on the computer vision that can identify objects and use this recognition, so this object as a tag, to categorize our images in OneDrive. Here we are in computer vision. You can easily find it by searching for Azure Cognitive Services and then browse to the computer vision service itself. Computer vision allows to build a powerful content extraction application by using a REST API with a pre-built model. What it means? It means that Microsoft has spent hours, weeks and months to pre-build the machine learning model with thousands and thousands of images of any possible type and then expose this as a very simple REST API to consume. What you see on screen now, which is quick demo, is a very blurred image of some people on a train platform. And the REST API has already recognized that there is a rectangle here with the coordinates of the rectangle. And this rectangle contains a person, contains a train, and you see there are some tags that identify a train with a specific level of confidence, a platform with a level of confidence, subway, and so on. What is the confidence? The confidence is a score between 0 and 1, indicating the likelihood that the recognition has been accurate enough, with 0 being I didn't recognize this at all, and 1 obviously being the most accurate recognition. So you can see here that there is quite a good recognition of a train, platform, even a person, despite being very, very blurred. I'll go into my pictures and let's select a car, for example. Okay, so I have different cars. Which one do we take today? Well, let's go for the Porsche. Okay, here we go. So I upload this image and you can see there has been a recognition immediately that we are outdoor, there is a car with a very high level of confidence, we are on the road, it is definitely a vehicle, and a few other things. Now let's pick another one. And I'll pick some flowers here. Here we go. And here we have is a plant, flowers, there are some roses, it's a bouquet, and probably some other flowers that I don't even know the names. but that's okay. I'll trust computer vision is doing its job really nicely. Now, how about we challenge it? So let's have a look into this one. What do you think this picture is? Is it a flower or is it a car? And now if we have a look into here, we'll see that there is a level of confidence that's very high, that flowers have been identified. But there is a lower level of confidence that a car has been identified. So look at here, car, confidence, the level of confidence has dropped significantly. It used to be 0.99 and now is in 76%. So what's happening here? Well, the model has been able to recognize some elements within this picture, but not good enough to distinguish whether it is a flower, a car, or a combination of it. And the reason is very simple. There are not many models, there are not many items, pictures that have been used for training these spatial conditions. How do we get started? Well, we have to start from Azure and create a computer vision resource from the marketplace, so then we can then use it, connect to this resource from Logic Apps. So here I am in my Azure portal, specifically in the marketplace. I'm about to create a new resource where I can find it. All these cognitive services are under the AI and machine learning capability or category, and you will see computer vision is just here. So click on computer vision and start filling the fields here for creating this resource. Give it a name and then choose a pricing tier. There is a free F0 tier that allows for 20 calls per minute and 5,000 in a month. I think that's plenty if you just want to practice with the Logic Apps integration and build a digital asset manager only for yourself. Obviously, if you want to scale these to a larger volume of traffic, the S1 subscription tier allows for 10 calls per second. So I'm in my computer vision resource that I provisioned in Azure previously. You have plenty of documentation on how to use the web API in C#, in Python, in Java. But what we need is to look at the key and endpoint that you will be using for connecting to this service from Logic Apps. Before we look into Logic Apps, let's brainstorm a little bit how this integration flow will look like. So the idea is when I upload a file into OneDrive, will be in a common folder where we dump all our pictures. I extract the content of the picture, analyze the image with the API that we have just seen, so with computer vision, and then this API will produce a list of tags or categories. So I will set a condition. If the score is, say, higher than 80%, so 0.8, I'll move the file into a folder named after that category. Otherwise, I'll create a log and move into the next one. Here I am in my Logic App Designer. I have created a flow that basically starts from OneDrive for Business. I have selected a folder where I'm going to upload all the images and the frequency of checking whether there is a file in this folder. And then I call the image, and then I call the computer vision API for analyzing this image. It's very simple. You just have to do a search for computer vision, and you will see that you have the computer vision API, and from here you select the analyze image. Okay, so I've already done this. So, and it is configured to select the file content as a dynamic content. So we're looking into analyzing the content of the image that has been uploaded in the previous step. From here, I just initialize a variable. The file has been created. This is my exit variable in the loop that I'm going to create now, because for each category, so for each category, you can see here, for each category in this flow, I set a condition. The condition is if the, here is not really visible, but if the category confidence is greater than 0.8, you can choose your own value, then branch into true and false. If it's true, I'm gonna move the file, and I'll move the file by picking the file by its ID into a destination path given by the category name / the file name. If not, I'm going to create a log file with a point log attribute in the category name equals confidence score as content of that file. At the end, I set the variable, so in case everything is successful, the file created to true, because this is my exit condition. So I'm going to activate this flow now and show you how it works by switching to OneDrive. So let's run it. So this is my OneDrive for Business folder. I'm in the image folder here. So I'm going to upload now a file and drop in here. So I'm going to do this from a collection of images, the ones that we have seen before. So I'm gonna go into my car that we have seen before. Let's take another one. Now this nice and beautiful yellow Beetle, and upload in here. File uploaded. Now we just have to wait about 10 seconds for this file to be picked by the flow and categorized. And as you can see, after a few seconds, the file has disappeared from my images folder. This is my dump folder where I upload all the files. Where has it gone? Well, I created through the flow a folder structure starting from the root, so I have to go one level up, and you see there is a folder here called trans car, it's a transportation car, and inside here we find our car. Beautiful. Let's do the same also for the flowers. So I'm going to close this, go back into my images, and upload a picture of a flower. Okay, let's take this other one here. And again, flower bouquet uploaded, 10 seconds until the process kicks off, and then we can see that this file will disappear from this folder and move into ideally another folder. I wouldn't expect to go into the same trans_car folder that has been created before, right? So the file is gone. Let's go and find out. One level up. And here it is in plant_flower. There is a new folder in here which contains our flowers. Beautiful. How about the tricky one that we used before? Was it a car or was it a flower? Let's find out. Just upload this Joe Maloney in London. So the file has been uploaded now, but it's not disappearing. It's not going anywhere. What's going on? Well, if I go back one level up again, this time I see no new folders or the file not being moved into either one, plant, flowers or transcar. What I see is a log file generated after the file name. So I'm going to open the log file, and as instructed in the logic app flow, you will see we have written inside this file the category and the level of confidence. Category is not even perfect. It's been recognized as a plant, but no other indication. Not a car, no flowers, nothing else. But more importantly, the level of confidence is much, much lower, so we cannot use it for automatic categorization. So how do we address the gap? How do we make computer vision learn that Well, that car with flowers is actually one of those pictures that we do want to recognize. So how can you personalize computer vision to make it specific to your needs? And this is where you actually need custom vision, where you can customize image recognition to fit your business needs by providing your own dataset and training this dataset using machine learning for your custom purposes. Now, the beauty of custom vision is that you don't have to be a data scientist again to do any of the training and categorization. Custom vision will do that for you. You just have to provide images. Let's have a look at how to do that. You start from the customvision.ai website. In this website, you can upload images, train them by just clicking a button, and then do an evaluation. Custom Vision will expose a REST API, a web service completely managed in Azure without writing a single line of code. And obviously, you can consume this REST API and use it in your own application. So here we are in computer vision. We need to sign in with your Azure account. And once you're in, you will see the list of projects that already exist. So ignore this one that is another of projects of mine. Let's create a new project for image recognition. So you can just say, call it here Digital Asset Manager, give a description, and use our Azure resource that you want to create. So you have to pre-allocate a resource in Azure, as we have seen before for computer vision. The same will be also for custom vision. And then you can have two types of projects, a classification project and an object detection. A classification project is what we are going to do now. So basically identifying the class, the generic category of an image. Object detection is a bit more specific. It goes into identifying the areas, the rectangles where an object is identified, detected inside an image. That's too detailed for what we need. We'll stick to classification. You can also choose whether you want to assign a single tag or multiple tags for each image. In our case, we'll stick to a single tag just to keep it simple for now. Obviously, if you have images that fall in multiple categories, then you want to assign multiple tags per image. Once you create your project, then you have to add all the images. You need at least 5 images to train the model. So let's start with our first 5 images. And we start with our cars. Not coincidentally, I have 5 images here for different cars. So I'm going to upload them and give it a tag. How do we call them? Well, this is a car. 5 images uploaded, job done. And you see they've been all tagged as car on the left hand side. You see there are tagged car, all 5 of them. Let's do the same for the flowers. So add more images and upload our flowers. And now we have a combination of car and flowers. Okay, so then just have to click the train button here on top. You see this green button? This will do a training of the dataset that we have uploaded. Because the dataset is not significant, I mean we have just few images, the bare minimum to do the training. It's going to be very, very quick. If you have a larger dataset, and this obviously the accuracy will be higher the more images you have, then it may take some time to get the training done, just a few minutes or even an hour, depending on if you have hundreds of thousands of images. And once the training is done, you get some statistics on precision, recall, average performance. Now, in this case, we are super good. We're getting 100% accuracy overall, simply because the images are very, very clear. So we have 5 cars, we have 5 bouquets of flowers that are clearly distinguished from each other. So the accuracy is pretty awesome. Now, in real life you can get images that are not that clear, not that sharp. So once you upload them, you get a precision and a recall that may be a bit lower. But aim for at least 90%. That is a reflection of the quality of your model to use this model, custom vision, in a production application. Let's do a quick test now. Now, for testing purposes, we cannot use the same images that we have been using for training, because otherwise it's quite obvious. The image is there, it's part of the model, so it will be recognized automatically. So it doesn't make sense for me to use one of these 5 flowers bouquets, because otherwise it's obvious that the model will recognize it if I pick this or this or that. These pictures are being used for training. I need to use another one, a 6th one, that is not part of the training model. So I'm going to go one level up, and you see I have some sunflowers here that has not been used for training. So I'm going to pick this, and as you can see, this has been recognized being a flower and not a car. What happens if I upload a bunch of apples or bananas or something else? It will not be recognized, because the only 2 categories that I have instructed custom vision to recognize are flower and car, nothing else. So I'm going to do the same also for a car. I'm going to choose this Toyota Prius, which has not been used for training, and I would expect this to be recognized as a car. So despite computer vision not knowing how a car looks like, but only based on the 5 images that I've used before for training, is good enough to recognize Toyota Prius as a car. And now let's go and do the challenge of the Joe Maloney. And here we go. We have again flower and car in ambiguous probability. It's more flower than a car, but still not a clear decision. All right, so we want to address this, and now we can. Because to address this, you just have to go back to the training images. So we have our flowers, we have our cars, we need a hybrid combination of them. So we're going to add some images and upload our car flowers, a combination of different flavors. I'm not going to use the Joe Maloney ones, because that one is my test. I'm going to instruct custom vision with some combination of cars here. Okay, I'm gonna call it flower car. It's just a tag. You can give it the name you want to, but something that is obviously distinguished from the other 2, and upload. And here we go. So now we have 5 cars, 5 flowers, and 5 flower car. All of them. I need to retrain the model. So click retrain. Okay, and once more we have a second iteration, very high precision again, because we have very clear, sharp images, and the 3 categories here: flower, car, flower, and car individually. All right, time for a quick test. And again, I'm not going to use any of the 5 images that I've been using for training the model. That will not make any sense. What I'm going to use another one, our Joe Maloney one, that has been troubled so far. And here we go. Job done. So Joe Maloney now falls very precisely into this 3rd category, flower car, whatever that means, and is no longer identified as a flower, is no longer being identified as a car with lower probability. 100% this fits into the flower car category. Time to you now to get in action, get started with cognitive services, and specifically with computer vision and custom vision. Computer vision, you have a full set of REST API completely documented and available on Azure. If you are a .NET developer, there is also a NuGet package, a managed package, which is just a wrapper around the API that can make your coding easier from a .NET perspective in C#. if you're building a custom app. Otherwise, if you're sticking to logic apps and this integration flow as seen in this video, in this demo, then you don't need to do any coding at all. Just connect logic apps to custom vision. The same, to computer vision. And the same also for custom vision. So there is also an action for custom vision. Custom vision expose a REST API. So you have just go through the same process that we have seen for computer vision, with the difference that you are loading your own images, you're training your own model, and then custom vision, the API exposed by custom vision, will use that model for its prediction. That's all for this session. Thanks for watching. Hope you find some interest and some ideas to make it better and more productive for your specific needs. I'm available for any follow-up questions. Please reach out on Twitter, on LinkedIn. My social coordinates are on screen. Thank you so much again. Have a great one.